One more question based on concepts of similar triangles. As you can see, we are given two triangles, ABC and DBC, and they are on the same base BC. This is triangle ABC, and the other triangle is this DBC. They are on the same base BC, BC being the common base on which these two triangles are there. Right, the base here, common base is BC. Right. What else we have been given that these diagonals AC and BD intersect at point O. And finally, we have to prove the ratio of triangle, area of triangle ABC, ratio of area of triangle ABC over triangle DBC is equal to AO upon DO. That means area of this triangle ABC to the other triangle DBC, the ratios is equal to AO over DO. For this, we are going to do some construction, and the construction involved here, as we cannot directly prove these two triangles similar and write AO over DO as area ABC over DBC. So we are going to use the formula area of a triangle is half base into height, and for that we will be drawing two altitudes. Let's say I'm drawing this as AM. We'll draw the altitude on the common base and this as DN, right? These two altitudes are drawn. And first we'll write the formula for the area of a triangle. As you can see, area, I'm starting from here, area triangle ABC over area triangle DBC, that is equal to half area triangle ABC, as the base is BC and altitude is AM as it is given in the figure. And for the other triangle is half into base is same BC and the altitude is TN. We can clearly see that half and half BC get cancelled. So finally we get the relation between these two as area triangle ABC over area triangle DBC is equal to AM upon DN. But when you see that, when you compare with the two proof thing, what you realize that we need this area as AO over DO and not AM over DN. So that means we need to get a relation between AM, DM and AO, DO. Right. So let's say if I mark this as equation 1, and we realize is that if we prove these two triangles, that is triangle AOM as similar to triangle DON, so we can write their sides as proportional, and therefore we will be replacing AO over DO with AM over DN. So let's consider the two triangles that we have to prove similar. So we are going to prove these two triangles similar. I'll start with, we'll write in triangle, that is AOM, and the other triangle as DON. We have one angle as 90 degree, right? These angles are given 90 degree. Moreover, its vertically opposite angles are also equal. So we'll be writing angle AMO is equal to angle DNO, and they are each 90 degree. And the other one, as I said, is vertically opposite angle. Angle AOM is equal to angle DON, and that is by vertically opposite angles. So therefore, the triangle AOM is similar to triangle DON, and that is by a similarity. Now, as you know that the purpose of proving these two triangles similar was to write their sides as proportional. So we'll be using this equation 1, right? Equation 1, and similarly, we'll be writing a ratio here, that is AM upon, as you know that once the triangles are similar, their corresponding sides, that is say AM over DN is equal to AO over DO. AO, we need to write AO first. AO over DO, right? This being equation 2. Now, what in case if I replace this? If I replace in this equation AM over DN with AO over DO as they are equal, right? So we'll be replacing and then we'll get this area. So let's do this. We'll write from equation 1 and 2, we can say that area triangle ABC, I'm writing from here, right? ABC over area triangle DBC is equal to, I'm replacing this AM over DN. As you know, AM over DN is equal to A over DO with AO over DO. And we'll say hence proved.